yeah, so it's my duty to entertain you for 10 minutes till the jury has made up their mind. Yeah, so we pitched 2 years ago with washing machines which had little devil horns, and the topic back then was what was it? So the idea was like, if you once buy a washing machine, then you will be followed by washing machines for years, right? Because like the way the recommendation works. And we said that we have a real-time approach which allows you to analyze the data in real time and to see that, okay, so yesterday he was very interested in washing machines, but that was only once, so maybe I can forget about it. Okay, we did not win the competition, but in fact, somehow Nugget was so interested in the technology we had, so that we since then started to work together. And like the targetometer, which Stefan Noller had in his hands this morning, so part of the analysis is actually powered by Streamdrill. So, yeah. So we didn't win, but it's still a nice outcome, I think, for us. Okay, and so today I'm talking about what is real time. Okay, so first we had what is real time. So first we had big data. We just gotten used to understanding what that is, and then now there is a new buzzword. So what is this all about? Okay. So I think the basic definition is that the difference between just big data and real time is that in real time you actually have to analyze the data as it comes in. Right? So you cannot just store your data somewhere for a few months and then crunch the data over the weekend to get some insights, but actually the data is coming in all the time, and you actually want to you have to do something with it. Okay, so typical example is like anything which is related to user data. We already had that a few times today. So there's this happy user here, and he's browsing the web. So this rectangle thing is a computer. And everything he does sort of gets into this log database, right? So like you go through a shop, you browse some sites, you click around. And so normally, like all this data is collected in some way because websites get more and more dynamic, and you want to put recommendations up there or other stuff, or show the user that which is he most interested in. Okay, actually I can look down here. So, and then for example, you crunch the data as it comes in, and then you find out he's interested in cars. So you can show him an ad about a car, or say, yeah, you can buy a new shiny car here. Or you can show him news-related cars or anything like that. And this is real time, right? So you can't just store the data and then crunch it overnight, and the next morning it says, so you're really interested in cars, and then you're like sitting at your breakfast and not really thinking about cars anymore. Okay, so this is like the original idea of Streamdrill. Our technology core was algorithms which allowed us to do that very quickly. And in the remainder of the talk, I'm going to talk about a few topics related to real-time, which try to explain what's so special about real-time big data. Okay. Yeah, so the first question is, why is real-time big data so hard? So even like the most basic things, the most basic analysis is just counting, right? So you want to know how often the user has gone to that website, how often he has been interested in that topic. So it's just counting, right? And then you probably want to also have these counts over different time frames, so you want to know what he was interested yesterday, what he was interested over the last week, and stuff like that. So it's not really hard, right? I mean, we all learn counting in school. So there are two things why this gets difficult pretty quickly. One is that you have to do it very, very often. So even when you start with 100 events per second, which is very little, I think, nowadays, then you end up with 3.2 billion events per year, and you have to track all of that. So earlier, the guys from Modelo, they were saying they have about 500,000 events per second, and then even counting already becomes quite a challenge. And the other problem is that in many of these kinds of event data, actually the data is talking about many, many different objects, right? So if you have a big website, you have maybe 100 clicks per second, but over a day you see like 1 million or more people, and you want to count for each of these users individually, right? So suddenly it's like you have to count a lot, but also you have to store a lot of information, and these are the two things which make real-time analysis big data. Okay. Yeah. Yeah, so the other thing, so one thing is, okay, so an important aspect is actually what you want to do with the data, right? So very often the data gets in and somehow you have the idea that you actually need to analyze it as it comes in. But then when you think about it, you can't actually really react to the analytics you get from the data, and that's very important. So for example, if you analyze like all the traffic to your website, but all you need is in the end is like a report on Friday, and then you sort of collect those for a month, and then you decide to change something, then that is in a way real time, but it's not really, oh sorry, I have to go over here. Okay, very good. Then it's in a way it's real time, but it's not really that hard because you can store the data and crunch it later on. But as you go down and down and you become more like programmatic buying and real-time bidding and all that stuff, you end up in a situation where you're analyzing the data and you really have like 1 millisecond to analyze all the data and have an analysis which reflects the latest state of the data. Okay? But so often, like when the data comes in, this is another like aspect of real-time. So the question is what can you do and how quickly you need the results. Okay. So then the other question is, so very generally speaking, how do you process the data, right? Because so the classical big data is what is technically called like a batch processing scheme, which means that basically you collect all the data first and then you do something with it and then you get a result out. And like all of the stuff, like Hadoop and MapReduce, that's all technology to make that kind of analysis very quick. Yeah. But as I said before, so when you have like 1 millisecond to get something out of your data, then you can't really do it like this because or even only if you have lots and lots of money, because it just takes too long. So even if it takes like an hour or so, or a minute, then it's just too long. So the other way, so the way real-time data usually is processed is using a streaming approach, where you have so the little, on the right-hand side, the little circles are, so to say, like little nodes which do some computation, and you process the data as it comes in. So it goes into your system, each of the nodes does a little bit of computation, and then you get the result out in the end. But it's something which is an ongoing process, okay? Yeah, and like if you, like all the modern systems which you do with real-time, you have to switch to the streaming kind of approach. Okay, and then a very important insight we had is actually that, so once you deal with real-time data, you really have to ask yourself the question whether you really want to have the exact results for your analysis. Because getting exact results, so the reason for that is actually you can get much faster if you say, it's okay if the results aren't exact, but I have like 5% error or 10% error, or maybe I even have an algorithm where I can sort of tune the amount of error I have. And that allows you to get very quick, very fast without buying new hardware. Okay, so some guys from a company called Akunu, they summarized this insight in this triangle. So on the top you have big data, so which means you have lots of data you want to process. And on the right-hand side you say, okay, I want to have the exact result, and on the left-hand side it says I want to have the result very quickly. And as in these triangles, so the rule is that you can only have two sides of the, like two corners of the triangle. So you can either have big data and exact, but then it's not really fast unless you put a lot of money into it. Or you can have fast and exact, but then you can't deal with lots of data. Or you can say, okay, I don't care about exact results, so I'm approximating, and then I can deal with lots of data. And this is, so to say, yeah, the technology we built. And for many applications, so people are always a bit, so it depends on the application, right? For some cases, like when you're doing billing for mobile phones, then you probably really want to know how much each of your users spend. But if you're doing, like, there are many kinds of data analysis, for example, trend analysis, or you want to identify, or like recommendations, so all these are processes which are already have a large margin of error, right? So then if you then realize that you don't really need to get the exact results, you can save a lot of money on the hardware. Okay, so how far are they? Looks good, okay. So lessons learned. Yeah, so real-time data, so in a way, like, I think the original big data, which came around like 2003 or so, was a bit different from the, like, where we are today, where lots of data we process is real-time, and we are building infrastructure like real-time bidding, where we really need to process data in real time. And for us, so the main lessons learned is, so you need to process the data as it comes in. You cannot store it somewhere. You have to go to in-memory, so you cannot even, not even in a streaming fashion, put it on disk, because disks are too slow. If you can approximate, if you have a setting, you can gain a lot of performance by approximating and focusing only on the relevant data. And the system we built, so just to give you some numbers, we're able to deal with about 20,000 events per second on a single machine, and track about 1 million objects per 1 gigabyte of RAM, right? So like on a single machine, on a normal server with 16 gigabytes of RAM, you can already track a few 10 million people or profile IDs or whatever, and deal with up to 20,000 events per second. And that's something like with using more, let's say, traditional big data technology, that's something where you would already need like 10 to 20 servers. Okay, so this is like, yeah. Okay, so this was my talk. I hope I didn't bore you too much, and I hope is the jury ready now? Otherwise I can tell some more stories.
Thank you very much for this talk.